Hey guys, so we've been talking about linear functions and how to graph linear functions, how to compare linear functions, and we're going to look at two forms of a linear function written as equations. Okay, now there's more than two forms that you can write a linear function, more than two ways, but the two that we're really going to focus on this year are standard and slope-intercept form. And both are perfectly fine ways to write linear functions. They're just used in different times. So your objective for today is that you need to know the two different forms of linear equations, standard and slope-intercept. You need to know what they look like, be able to recognize them. And you need to be able to switch back and forth between these two forms using the rules of algebra that we've learned and we've practiced. Make sure you're on page 46 and that the date is November 18th, 2013. Pause the video so you can get that written down. Make sure you're writing it neatly, and then go ahead and continue on to the next section. So we're going to look at standard form first. Standard form is when you have the equation written as so. Ax plus by equals c. And we'll talk about what all those different parts mean. I want you to continue writing this on page 46. Don't write too big because we're going to have to fit a whole nother slide on there, okay? So the a, the b, and the c in this equation are all just numbers. They could be 3, 10, 12, 0.5, negative 50. They're just all different numbers. And those numbers will change based on the situation that the function describes. Also, x and y stay as variables. You're used to seeing equations written with an x and a y and a whole bunch of numbers. We've been working with that. The variables represent the two things that are in a relationship in this function. For example, dollars earned per hour worked, or number of shirts and number of pants. They're the variables, and that is what's going to change when you go to, for example, solve the word problem or graph the function. This form is really useful when you're making algebraic calculations. Okay, what does that actually mean? Plugging in numbers for x and y. Okay, and there's some real-world situations that you really need to use this standard form for, and we're going to be talking about those in class tomorrow, what those kind of real-world situations are. Make sure you have all of this written down, and then we're going to talk about slope-intercept form, which is the second form of a linear function that you guys need to know by the end of this video. So slope-intercept form looks a little bit different. Hang on. This should not go on page 47. Just leave that, leave this on page 46. Okay, at the bottom of that page. Sorry guys, didn't mean to confuse you. So now we have slope-intercept form, which is the other form of the equation. And in slope-intercept form, you have y equals mx plus b. You might also see it written as f of x equals mx plus b. F of x means the function of x. So whatever rule you apply to x, and the rule would be mx plus b. Anytime you see f of x, don't get freaked out by it. It just means y. Okay? So in this form of the equation, m and b are both plain old numbers. X is going to remain a variable, y is going to remain a variable. The m is a really important number because that describes the slope. Remember, slope is the steepness, so that would have a high slope, and this would have a low slope. Okay, so that number determines how steep the function is. B is the y-intercept. The y-intercept determines where on my xy axis the graph will cross my y-axis. So for example, the y-intercept here would be right at that point. This form is extremely useful when you are graphing. It makes graphing very, very easy. And there are some real-world situations that are easier to understand when you put them into slope-intercept form. And once again, tomorrow we're going to talk about what those real-world situations are. So now let's go ahead and talk about kind of the tough part of this, which is switching back and forth between standard form and slope-intercept form. And it's really important to be able to do this well, because you need to in order to solve certain kinds of problems. So this should go on page 47. Once again, the date is November 18th, 2013. When you are changing something to standard form, maybe I'll erase that 4 and write 2. That might make more sense. So if you want to make it into standard form, you need to get all variable terms on the left and leave your constants, your plain old numbers, on the right. I spelled plain wrong, my goodness. You'd think I wasn't a math teacher or something. Plain old numbers. If you want to change something to slope-intercept form, you guys have done this. You did it on the quiz you took last week. All you have to do is solve for y. And in order to do all of these things, you're going to have to use algebra, and you're going to have to use, for example, that balance that lets us move things from one side of the equation to the other. So let's go through a couple examples. On the rest of page 47, I want you to split the page into 2, and we're going to do one example to rewrite it in slope-intercept form and another to rewrite it in standard form. Please write this description here on each side so that when you go back and you look at your notes later, you can realize what on earth you're doing, which one of those things you're actually doing at the time. So if we want to rewrite it in slope-intercept form, we can look to the notes that we just took. All we have to do is solve for y. So how do I solve for y? I want to get y alone in this situation. So I am going to use my balance, and I'm going to follow all the rules of algebra. Rules like you have to undo addition and subtraction before you undo multiplication and division. This is that lovely SADMAP, which is just PEMDAS backwards. So I need to get rid of this 4x that's being added on to my y term. I'm going to get rid of that by doing minus 4x minus 4x. That cancels out the 4x's on that side, leaving me with 2y equals 6 minus 4x. But actually, mathematicians are kind of picky about some things, guys. They really like this x term to be first. Okay, they don't like to have a number minus an x term or a number plus an x term. I don't know why. Well, I do, but they're just kind of picky about it, okay? So let's go ahead and we'll change this subtraction to adding the opposite, and then we can just switch the order of these two things. So now it's negative 4x plus 6. Okay, you with me so far? All right, let me erase this here, and we will slide this up. And now we still haven't really gotten y completely alone because y is attached to the 2 by multiplication. Once again, following the rules of algebra, we'll divide both sides by 2. And you have to be really careful over here on the right-hand side. You can't just divide this term by 2. You have to divide both of them by 2 in order to be legal. So you have to do this divided by 2 to everything on the right-hand side. My 2's are going to cancel, leaving me with y. Negative 4 divided by 2 is negative 2, and I'm going to bring my x down as well. And then 6 divided by 2 is 3. So I now have it in slope-intercept form. Y equals negative 2x plus 3. Negative 2 is the slope, which describes the angle of my function if I graph it. And positive 3 tells me where on the y-axis my graph is going to cross the y-axis. Anyway, sorry. So now let's look at how we write something in slope-intercept form and change it to standard. Okay, so when we change it to standard form, we can look back at our notes again. We need to get all variable terms on the left, and we need to leave constants on the right, or move them to the right if they were on the left originally. So here we go. We have a constant term here, my 4, and it's on the right-hand side of the equation, and that's awesome. I'm going to leave it there. So all I have to do now is take this negative 2x and move it to the left-hand side because I need to get all variable terms onto the left. In order to do that, once again, I'm going to use my rules of algebra to cancel negative 2x, I have to add 2x, and I'll do that to both sides. And that's going to leave me 2x plus y equals, I have this 4 left over here on the right-hand side, and I'm done. It's in standard form. All right, and you know how we talked about over here how mathematicians like to have the x term before the constant term? They're really picky. They like to have your x term before your y term. They like your variables to be alphabetical. So don't do y plus 2x. It's going to have to be 2x plus y. Okay? So those are the notes for the day. I want you guys to attempt this reflection. There's actually 2 questions for this reflection. I want you to take this first function and turn it into standard form, and my second function and turn it into slope-intercept form. Go ahead and type your responses into Edmodo, and I look forward to seeing what you have to say. Thanks, guys. You know,